Okay, we are going to be going over the 9.4 notes, which is the best method to solve any quadratic. So there are basically four methods that we're really going to go to. The first method is called the square root method. And the square root method is going to be used if it's in this form, where it looks like a parenthesis x minus h squared plus k, or ax squared plus c equals 0. Basically, the bx is missing. So in order to do that, we're going to get rid of adding, subtracting. It's like PEMDAS backwards. Get rid of multiplying, dividing. Then you get rid of the exponent. Don't forget your plus or minus when you take the square root. And then we're going to get x alone by working in the parentheses. So let's look at an example of that. Pause the video if you need to, when you're ready to write this down. Okay, let's go ahead and start solving. So our first step over here is to get rid of adding and subtracting. So in order to get rid of adding and subtracting, I'm going to get rid of this minus 48 by adding the 48. Remember that this right here is considered parentheses, so that's not until the very end. So we have a 4 times x minus 2 squared equals 48. Next step, let's get rid of anything that's being multiplied or divided. 4 is being multiplied, so I'm going to go ahead and divide that. And that cancels out the 4 here, which leaves me with just the x minus 2 squared. And 48 divided by 4 is 12. Our next step is to take the square root, and don't forget to get rid of that exponent and by writing that plus or minus in front of this 12. Now that's that key step, plus or minus, because there are two answers here. We can actually break down the square to 12. So 4 and 3, 4 breaks down to 2 and 2. All right, so the square and square root cancel each other out, so you're just left with the x minus 2. And then we have plus or minus. The pair of 2's go outside. The leftover 3 stays inside. All right, and our last step is to get rid of that minus 2 by adding 2. And when you add 2 to both sides, you are going to actually write this in a different order. You're going to start with the 2 and then put the plus or minus at the end. You cannot take it any further because of the radical, and that's it. All right, greatest common factor. Let's go ahead and take a look at that. So greatest common factor is going to happen when you don't have the c. If c is missing, all we're going to do is factor out the GCF. That means look for any numbers that divide into all terms, any variables that all the terms have, take that out. And then once you have that factored, you're going to split them up, set the equal to 0, and see what you get. Split, set, see what you get. All right, let's see an example of that. Again, don't forget to pause so you can write down all the steps. All right, let's take a look at the example here. Is there a number that we can take out of both of them? Well, they're both even, so I can go ahead and factor out a 2. Is there a variable they all have? They both have at least one x. So that's my GCF. I'm going to factor that out, the 2 and that x. Let's see what's left. If the 2 and the x is factored out, I'm left with just an x. Negative 8 divided by 2 is negative 4, and I already factored the x out, so there's none left. All right, now the next step is split, set, see what you get. We're going to split this up. This has an x, so I do make that equal 0. And then x minus 4 equals 0. All right, anything you have a number multiplied by x, well, x has to be 0 in order for you to equal 0. So really it's like dividing by 2, but 0 is the answer for this one. Here we would actually add 4, and x would equal 4 here. Okay. Again, that happens when you don't have c, so you can actually see you could take it out of both. All right, the next type of solving is the t-chart, and that's when you have all three terms. So that's quite a bit different from the very beginning. So always something missing on the other two. C was missing here, and B is missing here, or it's written in this different order. So in a t-chart, we're going to create that t-chart here by dropping down the middle term. Figure out what multiplies to get ax squared. We write it here. Multiplies to get c, write it here. And then you check by adding the cross product. You multiply cross diagonally here, and add it up. It needs to add up to be the bx. Once you get that to add up to bx, you have your factors. You write the factors across the top and across the bottom in parentheses, and then you split, set, see what you get. Let's do an example. Go ahead and pause it so you can write this down. All right, let's go ahead and do this problem. So I'm going to go ahead and do my t-chart. I'm going to drop down my negative 9x. And now I'm going to ask myself, what two things multiply to get 2x squared? Well, that's 2x times x. And then what two things multiply to get 5? 1 and 5. Now that's a negative 5, so one of these has to be negative. I'm going to go ahead and make this 5 negative because I know this is going to get me a negative 10, and I want that negative 9 there. So 2x times negative 5 is negative 5x. 1 times x is x, and, oh, I'm at 10x, sorry. 2x times negative 5 is 10x, and then 10x, negative 10x, plus x is negative 9x. So these are my factors across the top, across the bottom. So I'm going to go ahead and write those in parentheses. Across the top, I have a 2x plus 1. Across the bottom, I have an x minus 5. Notice this has an equal sign, so we are going to split these up and set them equal to 0. All right, first step here, I'm going to go ahead and subtract 1. So that leaves me with 2x equals negative 1. And last step of this, I'm going to divide both sides by 2. So I get x equals negative 1/2. Here I would go ahead and add 5, so x equals 5. And these are my two answers. Okay. All right, the last type was what we did just the other day, and that was when we had a quadratic formula. Now we only use a quadratic formula really when a t-chart doesn't work. So you always try the t-chart, and if it doesn't work, then we use the quadratic formula. We did have completing the square, but completing the square, you only need to use if you really like that method, and that's really when you have x squared by itself, and most of these have an a term. All right, so you create the ABC chart, and then you basically plug the a, b, and c into this formula. So let's go ahead and do a problem. Keep in mind that it needs to equal 0 before you can actually start. So I'm just going to make sure that you move it all to one side of the equal sign. That should be all equals 0 before you start. Oh, this is already equal to 0, so we're kind of ready to start. Let's do the ABC chart. Now when there's not a number in front of x squared, that's worth 1. This is 4, and that's negative 7. It's in the right order. All right, let's plug it into the formula. So the formula is this. We're going to plug that in. So it says negative b, so that's opposite of 4, negative 4, plus or minus the square root of b squared, b is 4, minus 4 times a, which is 1, times c, which is negative 7. This is all divided by 2 times a, which is 1. All right, you start inside the radical to simplify. So I'm going to simplify inside here. 4 squared is 16. Negative times a negative is positive. 4 times 1 is 4. 4 times 7 is 28. 2 times 1 is 2. All right, let's go ahead and simplify a little further. 16 plus the 28 gets you a total of, let me put this in, 44. All right, and then let's go ahead and divide that all by 2. 44 breaks down. Let's go ahead and reduce that. So 4 and 11, but 4 breaks down to 2 and 2. So I actually have a pair of 2's. That goes outside, and then the 11 that's left over goes inside. So negative 4 plus or minus 2 goes outside. 11's left over inside. And then last step, I can divide all of the outside numbers. Remember, it has to be all 3. You can't just do the first 2. All 3 numbers by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. 2 divided by 2 is 1. So we actually don't even need to write this over 1. So really what I have here is just a negative 2. And then plus or minus. And this is 1 times square root of 11. You could just write it as square root of 11. Okay. All right, let's go ahead and do the backside. And the backside is basically you just trying to figure out which method should you use. All right, nothing is missing. A, B, C. Nothing is missing, so you should try a t-chart. If a t-chart doesn't work, that's when you use the quadratic formula. So let's try the t. Two things that multiply to get 5x squared is 5x and x. Two things that multiply to get 1 is 1 and 1. All right, multiply diagonally here is 5x. Diagonally here is x. That does not add to 7x. And there are no other numbers that multiply to get 1. And there's no other numbers that multiply to get 5. It's just 5 and 1. So since the t-chart does not work, we have to use the quadratic formula. So that's going to be quadratic formula because the t-chart doesn't work. Okay, quadratic formula. Let's do the A, B, C chart. It is already written in the right order. So A is 5, B is 7, and C is 1. All right, let's go ahead and plug in the values into the formula. So it's x equals opposite of b, so that's negative 7, plus or minus square root of b squared, so that's 7 squared, minus 4 times a, which is 5, times c, which is 1, all divided by 2 times a, which is 5. Start with the inside of the radical. 7 squared is 49. 4 times 5 times 1 is 20. 2 times 5 is 10. All right, and 49 minus 20 is 29. And actually 29 doesn't break down, so that's as far as you can take it. All right, let's go ahead and try number 2. What method should we use for number 2? Well, let's take a look over here. It's missing something. So it's either a GCF or it's the PEMDAS backwards, which is called the square root method. And we're going to do the square root method because B is missing. We don't have a GCF. B is missing. So we're going to be using the square root method. Because our B, because the BX is missing. Nope, hold on. All right, so square root method is basically PEMDAS backwards. Get rid of adding and subtracting first. So I'm going to get rid of this by adding 100 to the other side. So we have 9x squared equals 100. Next, get rid of multiplying, dividing. So I'm going to get rid of the 9. And 9 and 100 do not reduce, so I'll leave it just like that. Now we get rid of the square. And in order to get rid of a square, we do what's called the square root. And don't forget, you have a plus or minus sign. All right, the square and square root cancel each other out. Excuse me. And then we have plus or minus. And 100 simplifies. The square root of 100 is 10. And the square root of 9 is exactly 3. So that's it. It's simplified. All right, let's take a look at this one right here. Oh, this is not even in the right order. So let's first get into the right order before we decide what to do here. So I'm going to go ahead and move it all to one side of the equal sign. X squared is over here and it's already positive. So I'm going to move the 7x to the other side. So 6x squared. And when I move 7x over, it'll become a negative 7x. And then the minus 5. I'm putting it in the right order as well. X squared, then the x, then the number. All right. Oh, it is 3 terms. Nothing is missing. I should try the t-chart. All right, let's see. What two numbers multiply to get 6x squared? Well, let's try 3x and 2x, right? It's all guess and check, and we have to see if it works. What are the two things that multiply to get 5? Negative 5, I should say. Let's try negative 5 and 1. All right, diagonally this way, 3x times 1 is 3x. Diagonally this way, negative 5 times 2x is negative 10x, and that actually does add up to negative 7x. So the factors are perfect. Across the top, 3x minus 5. Across the bottom, 2x plus 1. Remember, this equal sign means we're solving, so you have to still split this up and make each equal to 0. And so here we would have to add 5 and then divide by 3. And 5 over 3 doesn't reduce, so we're going to leave it as 5 over 3. All right, here we're going to subtract 1. 2x equals -1, and then divide by 2. And then the x is going to equal -1/2. Okay. So what did we do? This method is called factoring method, or the T-chart. Why? Because it worked. Now, if the T-chart doesn't work and you tried all the different numbers, then you would use a quadratic formula. All right, this last one right here, it's not equal to 0, so let's go ahead and move it over first. Let's move that 11x over to the left side because x squared is already positive here. So to move it over, you've switched the sign, -11x. Something's missing. Is it PEMDAS backwards or is it a GCF? It's the GCF problem. They both have at least an x, so I'm going to factor out the x. You have x minus 11 left. Right, split set, see what you get. This is already solved, and here we would just have to add the 11 over to the other side. So the method that we used was just to factor out the GCF. And that's because the C was missing. Okay. Notice nothing asks you to do completing the square method. You can use it if there's no value in front of x squared and the middle term for b is even. That's when you kind of can use that. So let's just practice completing the square method here. So remember, you bring that c to the other side and leave a plus blank. On the test on Friday, you will have to know all the different methods. Since this is positive 98, I move it over by making it negative. And just don't forget the plus blanks. All right, we're ready to go ahead and do that parenthesis here. Do you remember how to get that? It's half of 20. Half of 20 is 10. And to get this blank, you multiply 10 times 10. 10 squared. And 10 squared is 100. All right, so this is already factored from here. Equals -98 plus 100 is 2. To get rid of the square, we take the square root of both sides, and don't forget that little plus or minus. The square and square root cancel, so you have just x plus 10. And you cannot break down the square root of 2, so I'm going to leave the square root of 2. Last step, you have to get x alone, and that's subtracting the 10. And remember that you write the number in front of the plus or minus, so minus 10, of the negative 10, I should say, plus or minus the square root of 2. And that's it.